Hey guys, so this is the second problem we are going to discuss today. It's also a lighting 100, and we are going to start with examples here. So for each example, we are going to have n test cases, and in this example, we are going to have 5 test cases. And for each of the test case, we are going to have the length of the array, and this is the actual array we are going to have. And we are going to uh, transform this array into a non-decreasing array. So this one is already non-decreasing, right? And for this one, we hope to transfer it to something like this. So we can do one options here. So we can select a max of the current array and put the max in any of the slot in this array. So what is max? Max is the smallest number that doesn't appear in the array. For example, for this array, the max is 3 because 0, 1, 2, 3. 3 is the smallest that is not currently in the array, right? For this array, the max is 0 because 0 is the smallest that is not in the array. For this one, 2 is the smallest that is not in the array, right? So we can move the max to any of the positions in the array. For example, for the second test case, the first position we are going to choose is the third position, and we are going to move the max to the third position, right? Then we have an array like this. And then we are going to have 0 as the max. And we are going to move 0 to the first position. And then we are going to have a non-decreasing array, right? This is the final array we want to have. And in the output, we just need to output how many steps are we going to have. We have to have 2 steps. And the first step, we are going to move the max to the third position. And for the second step, we are going to move the max to the first position, right? So how do we solve this problem? So we are going to have a strategy. So the strategy is that first, we are going to calculate the max for this array. And we are going to move, let's say we have a max I here, and we are going to move this guy to the ith position. What does that mean? So our final goal is to move the, transform the array to 1, 2, 3, right? From 0 to n minus 1. We can also take this as an example here. So our goal is to translate this array into 0, 1, 2, 3, 4, 5, 6, right? So our strategy is to move the max I to ith position. And if the I is n, then we are going to move n to any of the positions that ai is not equal to I, because our goal is to make AI equals I, right? So that we can get the final array, right? If AI is not equal to I, we can replace it with N. And then we will have a additional, we can have a different max, right? So let's do this. Take this as an example here. So the initial max is 2, and we are going to move 2 to the to here, right? This is 2's position. And the array we are going to have is this one, right? And then what is the max here? It's 4. So we move 4 here. And what is the current max is 3, right? So we move 3 here. What is the current max is 1. We move 1 here. What's current max is 5. So we move 5 here. What's the current max is 6. We move 6 here, right? So that's it. It's really simple strategy. So to repeat that, if we find a max that is not n, we move it to position I. If the max is equal to n, we move it to a position that a position does not equal to position, right? So that's it. Let's take a look at the code here. So we'll iterate each test case. And for each test case, we're going to maintain a few data structures. One is not in place. The meaning of not in place is that if we have I, that AI is not equal to I, then we put it into the set of not in place. And this guy here is the numbers that is currently in the array. It is a multiset because there might be multiple same numbers in the current array, right? And this is a set which has numbers that are not in the array, right? So for example, in this array, for this example, 0 is not in the array, 1 is not in the array. So we are going to maintain these 3 data structures. And for each of the given numbers, we are going to check if AI equals to I. If not, we are going to insert I into not in place, right? Eventually, we want to make the not in place set empty so that we know all of the numbers are in place. And we are going to insert the current number in the array, right? So that we know that this number is in the array. And then we are going to check what are the numbers that are not in the array, right? We are going to iterate each number. And if we cannot find that number in the array, then we are going to insert it into the not in array set, right? Then let's begin our iterations to find the steps. So we can ignore the XX here. It's just for debugging, right? So if for not in array size equal to 0, that means all numbers are in the array, right? So in that case, we break. And this is our max. So max is the smallest number that is not in the array. So we can easily get it by using this function, right? Then we are going to pursue our strategy. So if the max doesn't equal to n, then we are going to update the structure. So previously max is a number that is not in the array. Now we are going to put it in the array and at the right place, right? So we remove it from the set of not in place. And we remove it from the set of not in array, right? Because we are going to put it in the array. And then we're going to erase it, erase the one we are going to erase, right? This is the current number that we are going to replace, and we are going to erase it. And then if we find out if the number that we are going to erase is not in the array anymore, then we are going to add it to the set of not in array, right? And all these steps are the steps that we keep these three data structures updated, right? And then we finally update the number in the array by put the max in at the right position, right? And if we find a max that is equal to n, then we are going to find a random location where the ai is not equal to I, right? So we are going to find it from not in place set. And the location is saved in this variable. And we are going to add the answer into the final answer array and erase that number, erase the current number, and replace it with n, right? And these guys are just maintain those three data structures. And eventually we are going to replace that number with n, right? So we continue these two steps and until all the numbers are in place. That means we get a non-descending array. In the end, we output the final answer, right? So that's it. Hope it helps. Thank you for watching. Bye.